Tutorial 7, question 7. Show that x dz dx plus y dz dy is equal to minus 2z brackets 1 plus z. Z is a function of x and y, so we need to find dz dx and dz dy. To find dz dx, we differentiate z with respect to x, treating y as if it was a constant. So we start with the differential of 1 over x squared plus y squared minus 1. For simplicity, I'm going to put that on the numerator. So I've now got minus 1, a function of x to the power of minus 1. So now I've got a function of x to the power of minus 1. So I'm going to get minus 1 times the function to the power of minus 2, and then I have to multiply by the differential of this bracket. Y is a constant, so that disappears. 1 is a constant, so that disappears. So I've got the differential of x squared, which is 2x. So putting the bracket back on the denominator, I'm going to get minus 2x over x squared plus y squared minus 1 all squared. You can probably see now what dz dy is. We just interchange the x and the y values. So we're now going to get dz dy is equal to minus 2y x squared plus y squared minus 1 all squared. We'll substitute dz dx and dz dy into this equation to give us, there's a minus 2 in both terms and this bracket as well, so I'm going to take one of these brackets outside. So I'm going to get minus 2 x squared plus y squared minus 1 outside x squared plus y squared over the other of the brackets. Okay, this is obviously minus 2z. There's z for you. So this is minus 2z, so I'll replace that. So there's 2z. Then I'm subtracting this term and adding the same term, which has a net effect of 0. Next thing I want to do is to put these first two terms over a common denominator, which gives me this expression here. Clearly that will cancel with that and give me 1, and this term here is z. So that means I can now rewrite that as minus 2z brackets 1 plus z.